Linux links. So, for every file in our file system, there exists an index node or an inode. An inode is like a database of a file. So, it contains many information about the file. However, it does not contain two important things. It does not contain the file content and it does not contain the file name. So you can think of an inode like a personal ID or a passport, but without your name on it. Typically they contain the following: the inode number, which is very important as we will see, file size in bytes, the owner of the file, permissions, file type, number of link, etc. Here we will focus on links. There are two types of links. The first one is soft link. So if you are familiar with Windows, you will know what is a shortcut. And basically a soft link is the same like a shortcut in Windows. Soft link sometimes is also known as symbolic link. So if you know what a shortcut in Windows is, you will probably know that it's a pointer, it's a file pointing to another file, right? And you'll also know that the file size of a shortcut is usually smaller than the file size of the original file. And here we have the same concept. However, you have to know one more thing, that an inode number of a soft link is different than the inode number of the original file. So here is a visualization of soft links. Here we have an original file with an inode number of 100, and we have two soft links or two shortcuts, one with an inode of 200 and one with an inode of 300. As you can see, the inode numbers differs when we are dealing with soft links. If we delete the original file, the soft links will become useless. Pretty much like shortcut in Windows, right? If you delete the original file, the shortcut will be useless. There is another type of link in the Linux file system. This one is called hard link. So, a hard link is basically a different name of the same file. So it's pretty much the same exact file, unlike a soft link. It has the same file size like the original file. So you can think of it as a shortcut. However, it has the exact same file size and the exact inode. So you cannot actually differentiate between an original file and a hard link. Here's the visualization of a hard link. So here we have an original file which has an inode number of 100, and we have two hard links. Observe here that all three files have the exact same inode number, and all three files have the exact same file size. And if you delete the original file, this will not affect by any means the hard links. They are kind of like a copy. It's like a copy, not a shortcut, right? So you can think of a soft link like a shortcut, and you can think of a hard link like a copy of a file. So next video we will learn how to create soft and hard links using the commands. Ciao. I'll see you next video.